Hello, 6th grade math students. This is chapter 7.4, Expanding and Factoring Algebraic Expressions. This is really fun, and I hope you like it as much as I do. Let's get started. We're going to begin by learning how to expand with the distributive property. So if you see a problem that looks like this, it says expand, and then it's going to give you an algebraic expression, 2 times r plus 8. So 2 times r plus 8 means that we have two groups of r plus 8. So this is going to be very similar to collecting like terms and simplifying. So what we're going to do here is we're simply going to use distributive property now to expand or multiply 2 times r plus 8. So we would write that like this, 2 times r plus 8 equals. So remember, to distribute, we're going to take 2 times r, which is going to give us 2r. Then we move over our sign. Now we take 2 times 8 to give us 16. Voila! You've just expanded the expression 2 times r plus 8. All you're doing is using the distributive property to show what the final result would be. Okay? So if you wanted to understand the lingo perfectly, this is the simplified form, 2 times r plus 8. 2r plus 16 is the expanded form. These are equivalent expressions, meaning they're equal to the exact same amount, but they're in different forms. Okay? It's kind of like switching back and forth between an improper fraction and a mixed number. They equal the same thing, right? You're just writing them in different ways. Okay, let's do another problem like this. We're going to expand 3 times k plus 6. So that means we have 3 groups of k plus 6, or k plus 6 plus k plus 6 plus k plus 6. So you can think about it in 2 different ways. You can either write it as an addition problem, k plus 6, k plus 6, k plus 6. That's more difficult. I would recommend that you use that distributive property to simplify this. So 3k plus 6. Now we're going to take 3 times k to get 3k. We move over our sign, plus. Now we take 3 times 6 to get 18. So our expanded form is 3k plus 18. If we wanted to read this as a sentence, we would say 3k plus 18 is the expanded form of 3 times k plus 6. Okay? Once again, these are equivalent expressions. If we inserted a value for k, you would see that we would get the same answer. So let's say that k equals 2. If we took 3 times 2 plus 6, we would get 3 times 8, which is 24. If we took 3 times 2 plus 18, that would give us 6 plus 18, which equals 24. So you can see that these expressions are equivalent. Now, let's have you try a few problems on your own. Here are 10 practice problems for you to try. For the problems in green, please expand each expression using the distributive property. For the problems in red, please state whether each pair of expressions is equivalent or not equivalent. Okay, press pause while you work, and when you come back, we will learn to factor, which I love. So work fast so we can get to factoring because it's really fun. Go. And here we are to factoring. To factor an expression, we're going to look for common factors in the terms of the expressions. Factoring is quite literally the exact opposite or the reverse process of expanding. Okay, so let's say we expand this expression 3 times 4z plus 1 to equal 12z plus 3. We can now factor the expression 12z plus 3 to equal 3 times 4z plus 1. They're exact opposite processes. So let me explain how this actually happens. Let's say we have the expression 2y plus 10, and we're asked to factor that expression. So the first thing we want to do is list the factors of each term. So the factors of 2y, what times what would give us 2y? The factors would be 2 and y. Now the factors of 10 would be 2 and 5, because 2 times 5 is 10. Okay? So what we're going to do is we're going to remove the common factor, and we're going to put it at the very front of our expression. So we'll take out our 2, and we'll put it at the front. Now we put a parentheses in, or an open parent in. What factor did we remove from 2y? We removed 2. So 2y divided by 2 leaves us with y. Now put our sign in. Okay. Now let's look at 10 and take out our common factor of 2. If we divide 10 by 2, we have 5 left. There it is, 5. So our factored expression, or our simplified expression of 2y plus 10 is 2 times y plus 5. See how that works? Okay. If you want to check your work, you're going to reverse the process. So we're going to take 2 times y plus 5, and we're going to factor it. 2 times y is 2y. Move our plus sign. 2 times 5 is 10. Yep, these are equal. So we factored our expression correctly. Let's try another. Now let's factor 6z minus 9. So our first job is to list the factors of each term in the expression. What times what gives us 6z? Well, 6 times z. Are we done though? Nope, because 6 has its own factors, doesn't it? And its factors are 1, 2, 3, and 6. So our factors for 6z are actually 1, 2, 3, 6, and z. Now let's factor 9. Our factors for 9 are 1, 3, and 9. Okay? So now we want to look for our greatest common factor between 6z and 9. What is it? It's 3. All right. So now we're going to go back to our expression, 6z minus 9, and we're going to remove 3 from each term. All right, so our first way we'll express this is we'll take out 3. And that will leave us with 3 times 2z, right? Minus, if we take 3 out of 9, we have 3 left over, 3 times 3. Now we can rewrite this by pulling out our 3, putting it at the front. Draw your open parent, drop down your 2z, bring in your sign, and leave your remaining 3. So our factored expression is 3 times 2z minus 3. Okay. Remember, you can check by re-expanding. 3 times 2z, 6z, minus 3 times 3 is 9. Yep, so we must have done our division correctly because our expressions match. Okay, here are 10 factoring problems to try on your own. I realize that's quite a few, but since this is a brand new skill, we need to practice a lot. These 10 problems bring us to the end of chapter 7.4. When I see you tomorrow, we'll do lots more practice on expanding and factoring, and I hope you learn to love it as much as I do. I'll see you tomorrow. Have a great night, and thanks for your hard work learning this brand new skill.